So at this stage, it is good to know that what is the equation which we are trying to estimate. So recall we were trying to estimate a regression equation of this format. So given our problem, what is y? Y is the candidate vote percentage. Beta 0 is the intercept term. So this is the intercept term. In other words, beta 0 we have estimated to have a value of 8.32. What is our x1 variable? X1 variable is age. What is beta 1? That is 0.109556. X2 is a variable which will take a value of 1 if the party is a national party, and it will take its value 0 otherwise. What is the coefficient of x2? That is 9.02. x3 would be a variable which will take a value of 1 if the party happens to be a regional party, and if it is not a regional party, then it takes a value of 0. So beta 3 has a value of 26.05. So this is exactly what we have done in terms of generating a regression equation. Now that we have done that, the first question is how good a job have we done? For that, we need to look at what is called the adjusted R square. The adjusted R square here is 0.4981, which is roughly 50%. So what it means is that 50% of the values in y, or the fluctuations in the values in y, are explained alone by these 6 variables. Which means if you look at all the values of y, there are 1699 observations which we had. If you look at their values and how they differ from each across, and if you were to look at the corresponding values for their age and party, criminal, so on and so forth, you would be able to do a accurate estimate of about 50% of these observations. Now, is that a good number? Yes, given that we do not have an a priori theory, we are doing a very simple regression. This is a good enough indication, because what we are trying to say is you can look at a candidate, you can predict that what is going to be roughly the vote share of this guy in the constituency, and you will be right roughly half the times, which is itself is a reasonably good predictive power. Now let's look at these coefficients. Now that we know it's a reasonably good predictive equation model, the next thing is, are all these variables playing a role, or is it that some of the variables have no role to play in the regression? Supposing if there were some variables which has no role to play in the equation, then we should drop those variables from the regression. So what do we have here? Age, does it play a role? To find out whether age plays a role or not, we look at the t-statistics. Okay? From your statistics primer courses and the lectures which you had, you know what the value of t-statistics is. You also know that a high t-statistics value indicates that it's a highly significant variable. So how high is high? A rule of thumb, anything above 2 is high. Alternately, we can calculate the probability values, and if it is extremely low, then it is very significant. So how did one calculate the t-statistics? It's a very simple calculation where the t-statistics is calculated as the coefficient, that is let's say beta 0, by the standard error. So that would be the t-statistic value for the intercept term. So that's 4.6053. I can similarly generate the t-statistics for all the value. How significant is it? I will do a 1 minus the probability value reported to get the significance level, and I find that each one of them are significant at a very high level, at almost 99% significant level, which means all the 6 variables which I have used have some role to play or significantly explains the vote share a candidate is going to get. Okay. The next step in interpretation, now that we have found out that the variables are significant, is that do the variables have the right kind of signs in front of them? So what we have some of them positive signs and one of them negative sign. Remember, we will not be able to interpret anything on the sign of the intercept. So we do not try to interpret whether the intercept sign looks all right or not. We should only be focusing on whether these variables have the right sign. So what does a positive 0.019556 mean? It simply means between two candidates who are otherwise same on all these parameters. If you pick up two candidates and have one candidate 5 years older than the other, then the chances that the older candidate will get more votes is very high. In other words, if you have two candidates, one whose age is 50 and the other whose age is 45, then the candidate who has 50 years, who is 50 years old, is more likely to get 5 times 0.10, that's about 0.50 percentage of more votes than the other candidate. Let's move to national and regional. So how have we coded the variables national and regional? You recall the national variable was if the candidate is from a national party, then he gets 1, otherwise he gets 0. Okay, which means if you pick up two candidates such that one candidate is from a national party and the other candidate is neither from a national nor from a regional party, is an independent candidate, for example, then the candidate who is from a national party is likely to get 9% more votes than the candidate who is from the independent candidate, with an independent candidate. Similarly, if you pick up two candidates, one who is from a regional party and one who is neither a national or a regional party, an independent candidate, then the candidate who comes from the regional party is likely to get 26% more votes than the candidate who is an independent candidate. If you pick up two candidates, one who is a regional party and the other is from a national party, then the candidate from the regional party is likely to get 17% more. That's 26 minus 9, 17. Is likely to get 17% more votes than the the party from the national candidate. So basically put, if you have two identical candidates in all dimensions, they are of similar age, both of them are, let's say, graduate, none of them have criminal records, and both of them are the richest guy in the constituencies. If you pick up two candidates, and the only difference between them is that candidate A is from a regional party, whereas candidate B is from a national party, then the candidate A is likely to get 17% more vote than the candidate B. It's more likely the candidate from the regional party is going to win. Remember, this result is only for the assembly election of West Bengal 2011. We cannot use that to predict what is going to happen in the Lok Sabha elections or assembly elections in some other states. This is only for a specific problem. What about graduate? Well, if you are a graduate, if a candidate is a graduate, he is likely to get 6% more votes than a candidate who is not graduate. What about criminal? Not surprisingly, a candidate who has a criminal antecedents or a criminal record is more likely to get 6.82%. So that's roughly 7% more votes than a candidate who doesn't have a criminal record. What about asset rank? Now, if we notice that the asset rank is simply a rank, so rank 1 means you are the richest and rank 10 means you are the poorest among the lot in the constituency. So if you are a rich candidate, more likely, so then your score for the rank is going to be only 1. If you are the poorest candidate, your score is going to be 10. So a rich candidate will be minus 2.6 times 1, whereas a poor candidate will be minus 26. Roughly put, a rich candidate compared to the poorest candidate, who is rank 10, is likely to get 24% more vote share. Now, how do I come to this calculation? We'll try to create some simple examples to get there. So how do we do it? So let's define two candidates. One candidate is A and another candidate is B. And how do we define on the various parameters in terms of parties? A is a national party and B is an independent candidate. What are their respective ages? Let's have candidate A whose age is 50. Let's have candidate B whose age is 60. Okay. In terms of education, let's have candidate A who is a graduate and let's have candidate B who is not a graduate. Crime records. Candidate A is clean and candidate B has some crime record. Yes. You're just creating an example. In terms of asset rank, candidate A happens to be the richest in the constituency, whereas candidate B asset rank in terms of it is, let's say, 8. He's the 8th person. So A is the richest, B is the 8th person. Okay. So how do I find out who is going to get what percentage of votes? So I do a very simple part. So I've just copied the intercept and these terms, and let's put up candidate A. So what are the scores he's going to get? For intercept, that's common to both parties. So both should get 1. So what about B? B also gets 1 for the intercept. Now let's move on to age. Candidate A is 50 years old. Candidate B is 60 years old. One of them is from the National Party, which is candidate A. So he gets a 1 out here. Okay. Whereas B is not a National Party, he gets 0. Candidate is National Party, he is independent. So none of them are regional parties really. So both of them are 0. Candidate A is a graduate. What about candidate B? Candidate B is not a graduate. Candidate A has no criminal record, but candidate B has criminal record. In terms of asset rank, candidate is the richest guy, and this guy has a rank of 8. So what is the vote share which we have? To get the vote share, it is going to be beta 0 plus beta 1 x1. So I am doing for vote share for A. Vote share for A, and similarly I am doing vote share for B. And all I need to do is now replicate this formula, which is this times this, and I drag it, because each of the terms is nothing but beta 1 x1, beta 2 x2 for A, and similarly for him, for candidate B, I do this, and I have this. So what is the vote share which I am going to have? Okay, I get 26.4219 and have 0.81753. So what does it mean? Which means between these two candidates, A is likely to get 26% of the votes and B is only likely to get 0.81% of the vote. So this is fairly a simple way of predicting what will be the vote shares of two candidates who may be of very similar background, maybe diverse background in a constituency. Okay. Now this entire exercise is done without any a priori theory. So if we had a theory, and indeed there are some theories, what people think drives how much vote a candidate is going to get in an election, then if you could have put that theory and defined some additional variables, we may have gone from an adjusted R-square of 50% to maybe 75%. In absence of that, we have a reasonably okay predictive model of what is going to be the vote share of candidates in the assembly election of West Bengal to 2011. Okay, so that's step number 1. Step number 2, which is always very critical when you do analytics, is that you have a set of data, you get a result. Do you have any way of cross-checking the results which you have put up means anything? Is there any way to verify that whatever you're predicting is how far is it from the truth? So what is the way to do that? So let's look at some of these coefficients, and let's for the time being only focus on regional and national. So what does it say? That if you're a regional party, you're likely to get 26% more votes. If you're a national party, you're likely to get 9% more votes. Compared to whom? Compared to all those candidates who are neither national or regional parties. Now flashback to West Bengal election 2011. The incumbent party was the Communist Party of India, and they were a national party. Okay. And they lost that election after 30 odd years to Trinamool Congress, which is a regional party. And therefore, what we are saying is the anti-incumbency effect, which means because Trinamool Congress was the regional party, or AITC was the regional party and they have won the election, what we get is that in general, the candidates from the AITC were likely to get much higher percentage of vote than any other parties, including the other national parties, where basically if you now go back to the data, you will realize that by other national parties, it is mostly the Communist Party of India. So does this result make an intuitive sense? The answer at the first cut is yes. Is it possible that we have missed out certain variables which could have done? The answer is again yes. How do we get those variables? That we need to be able to understand the theory somewhat and ask for some more variables. But at this stage, we started by looking at the following, that when we are trying to do a predictive model, we need to first identify the y variable. So did we had a clear definition of the y variable? In this case, the answer is yes, it's the candidate vote percentage. The next thing was to identify set of x variables. Now, given the constraint in the data, the set of x variables which we identified, and when we think it could have, it could play some role, well, like the age of the candidate, or the kind of party he comes from, or whether the candidate is educated, or does the candidate have a criminal record. Is the candidate quite rich compared to others? So these are the set of variables which we identified. We then created some proxy variables. The proxy variable was converting from total assets to the asset rank. We ran a regression and then we got a model which can be fairly used for predictive purpose.